Hello, everyone, and welcome to this session of Bioinformatics Bootcamp called Introduction to Python for Biomedical Machine Learning. So let's go ahead and jump into the orientation. So the first question that we often like to address in these workshops is what the point is. Why another workshop for dealing with a topic as ubiquitous as machine learning? Well, the reason to us is pretty straightforward. We know that those who know programming and bioinformatics, they'll be more effective at their research. They'll be more competitive for jobs and for funding, and they'll be more flexible and adaptable to changes in their field. We found when we looked across the biomedical research space that there was tremendous interest in formal bioinformatics training, yet the opportunities for this kind of training are quite sparse. So we decided that we would create these workshops. And the idea behind this is that if you are someone, particularly from a biomedical research background, who wants to break into bioinformatics topics such as machine learning, these resources should be made available to you in a manner that is relevant to your biomedical research, which is what we found was really not out there. But for this topic in particular, we're particularly interested because we get to talk about machine learning, or should I say machine learning. We find this to be an incredibly useful and interesting topic for all areas of biomedical research. And it's got the power basically to revolutionize how we go about doing biomedical research in the first place. The data sets are out there, the code is out there. What's really needed at this point is an understanding of how to use these things to learn new things and to build models that can save lives. And so this is where we see a really exciting place for machine learning in the biomedical research field. So we're very excited to talk with you about it now. So let's talk a little bit about the logistics of the workshop. So most of the sessions will be 2-to-1 lecture and hands-on activities, okay? Just again, to reiterate, the lectures are being recorded. And so if you do not want to be recorded, make sure you turn off your camera and you turn off your microphone and you leave them off. Okay. Please post any questions that you have in the chat. And when we get to a point where we can stop and address them, we will do that. We'll also have periods during this where people can unmute and ask their questions out loud. But as we're going along, it'll just be more efficient for us to deal with those questions in the chat as we're talking. And the reason is because we've got several people here who are actually sort of helping to TA, who are going to be addressing those questions as they come up. All right, so, oh, one second here. Let me put on my focus assist. Sorry about that. Okay, back to it. All right, so this course is going to be in 2 parts. The first part is Python for data science, and this is basically where we're going to give you basic Python programming skills, especially for those who have never coded before. The first module is going to be Introduction to Python Programming. That's what we're going to be doing today. We're going to move on to Intermediate Python, Python for data science, and then finally, we're going to have a review week where we will go back through all the questions and concerns that arose during the first 3 modules and make sure that everyone feels comfortable before we start part 2. For part 1, we're going to be talking about data structures, if-else, loops, functions, NumPy and pandas, matplotlib, and probably most importantly, what environment are we going to be working in, which is, of course, Jupyter Notebook. All right, so let's now talk about the second part of the workshop, which we call Intro to Biomedical Machine Learning. This is where Dan Montemayor, who I'll talk about in a minute, is going to take over, and he's going to teach you about the basics of machine learning, specifically for the biomedical research context. So we're going to start by talking about how you can get to know your data, feature selection and parsimony, supervised machine learning models, end-to-end machine learning workflows. And then we're going to have sort of a capstone where we go through the process of actually taking real-world patient leukemia data and predicting clinical outcomes. So that's going to be in 2 parts between modules 9 and 10. And then we're going to wrap things up with a brief intro to computer vision for biomedical applications, along with a discussion of advanced topics such as deep learning. For part 2, we're going to be going through a lot. So don't worry about if any of this seems confusing at first or it seems overwhelming. The truth is that by the time you get to these topics, you will be well prepared to understand them. Most importantly, by the end of the workshop, you'll gain the skills and confidence to use Python and machine learning in your research. So, how do you succeed in this workshop? Well, the first thing that you really need to be doing is completing the assignments on DataCamp. The fact that you're all here with us today means that you have actually been doing that, which is excellent. That's probably one of the most important things that determines who will actually be successful in the workshop. But of course, you want to pursue outside learning as well. So there are other resources such as Codecademy, online books, etc., that allow you to learn in different contexts and get a more well-rounded perspective on Python and machine learning. And then finally, make sure you're communicating with your instructors. You can email us at any time, and we have Zoom office hours, which are listed in the syllabus. And if you want to know where you can find that, it's on the course website, which is in the chat. So go there, download the syllabus, and you can find our office hours there. I think at this point, Dan and Simon we might not have posted them yet, but we'll make sure to add them soon if we haven't yet. Speaking of your instructors, we've got Dan, Simon, and myself. So Dan is the main instructor for this workshop. He's going to be taking over and running part 2. And he's an assistant professor in the Center for Renal Precision Medicine in the Department of Medicine here at UT Health San Antonio. He's got tremendous amounts of experience in machine learning, particularly in the biomedical context. And so he's the one who is really going to be giving you those biomedical machine learning skills. Simon and myself, we're a little bit less experienced, but we can definitely teach you the Python side. So we're going to be together teaching Python and Python for data science. We're both PhD students here at UT Health San Antonio. He's in his 5th year, I'm in my 3rd year, and we both use bioinformatics to varying degrees in our research. Finally, I'm going to talk about Big Club. So this is a student-led organization at UT Health San Antonio. We're the ones who bring these workshops to you, and we are very welcoming of anyone who wants to be involved in helping us set up these workshops or helping us set up our seminar series or our sort of, I think we're calling them coffee breaks, chalk talks of sorts, where we talk to each other about various techniques in bioinformatics and we help each other understand them. And so if you're a UT Health San Antonio student, you are more than welcome to attend. Feel free to reach out to myself or to Muku, who's also on the call with us today. So just again, where do you get the course website? Well, you can go to bigbioinformatics.org and navigate to the workshops where you will find the Intro to Biomedical Machine Learning in Python workshop. One more logistical point, if you find yourself needing help, there are many resources for you out there, many online in particular. So BioStars, Seek Answers, R Bioinformatics, it's on Reddit, of course, Stack Overflow and GitHub. And finally, there's us. We're happy to help you at any time. And really, if you find yourself struggling, you are more than welcome to reach out to us in office hours. Okay, so before we jump into sort of the introduction to this course, giving you some of the background and underpinnings of why machine learning in the biomedical context, I just want to really quickly take any questions. So does anybody have any questions so far about what I've talked about? Feel free to unmute or put in the chat. Okay. Well, if there are any questions that come up at any point as we're going along, you are more than welcome to put them in the chat or wait till I stop again, just like I did just now, and ask them by unmuting. So either way. Okay, let's get into it. There we go. So let's talk about machine learning. But before we talk about machine learning, let's talk about what we as biomedical researchers typically do. So here's the typical workflow for bioinformatics and biology research. We typically start by having a biological question. Sometimes we call this the big biological question. But this typically leads us to generate a hypothesis. We follow this up with exploratory analysis. If we find something interesting, we do confirmatory experiments, and then we publish. So here's a really brief example of that in action. This let's say hypothetically, is a protein I study called SLC16A2. Let's say that I study this protein in the context of cancer. I've recently started to come to a hypothesis that SLC16A2 causes breast cancer progression. Okay, so I might go on to do an exploratory analysis using, because I'm a bioinformatician, a service such as Jupyter. Now, without going into the details of how you do this analysis on Jupyter, just know that you can do it in about 30 seconds and it requires very little technical skill because Jupyter is a web server that is designed to help make these kinds of analyses very easy. But let's say that I want to analyze whether there's a relationship between SLC16A2 and the survival of breast cancer patients. I do that analysis here, and this is the result I get. Now, for those of you who are unfamiliar with survival analysis, what this is essentially saying here is that the group of patients that have high expression of SLC16A2 survive worse. Okay, so the percent of that group surviving is much lower at various time points as you go along. So at 50 months, fewer of them are still alive. At 150, far fewer are alive. And the difference between the low and high SLC16A2 group is quite significant. And so what does this tell us? Well, this tells us there's at least an association between SLC16A2 and breast cancer prognosis. So what have I done so far? Well, if you look at our workflow here, I've essentially done the first 3 steps, which is to have the question, generate a hypothesis, and do my exploratory analysis. Now I might go on to do some confirmatory experiments. Perhaps I have a mouse model that I want to use to confirm that there's this relationship. And then if all goes well, I publish. And that makes me very happy. But if we think about it in another way that's not typical for a biomedical researcher to think about things in, we could say that, well, we now know there's this relationship between SLC16A2 and breast cancer progression. And what if we could actually use that information clinically? What if we could use that to save lives? What if we could use this knowledge to predict things such as patient outcome or drug efficacy or remission rate? There's a lot of good that we could potentially do for a lot of patients. If we look at the workflow of how this might fit into current clinical practice, you actually arrive at something we call precision medicine or personalized care. This is kind of what that might look like here. So let's say that you have some breast cancer patient. You could biopsy their tumor. You can measure the expression of this gene or perhaps other genes that also are predictive of outcome. You could include them in some kind of model that can tell you whether or not that patient is going to be sensitive to a particular treatment, whether or not a particular treatment would work, or if nothing else, at least what their prognosis is. It might give you a better idea. And this is really the whole point of a lot of biomedical machine learning. It's a logical extension of what we're already doing as biomedical researchers in the basic sciences. It's a logical extension of that, but it goes further. It enables precision medicine and it has potential to save lives. So I hope you can see why, from my perspective, this is such a worthwhile thing for us to be pursuing. All right, so with all that being said, let's first jump in by asking the question, what actually is machine learning? It's something that you hear a lot probably on the news and probably in various social media circles, but many people have sort of a misunderstanding of what machine learning is. And that's partially because people don't really understand what AI is. So if we think about what the actual definition accepted for AI actually is, we would say that it is simply the science and engineering of making intelligent machines, especially intelligent computer programs. But this can include a lot of stuff. So we see that this can include both machine learning, but also just generally statistical analyses of data, expert system-based if-else statements. So like, for example, if I'm trying to predict whether or not someone has diabetes, I might come up with some protocol that says if the patient has a glucose sensitivity greater than 10, then they have diabetes. If it's less than 10, then they don't. I might come up with that as an expert if I was a doctor in that field, right? So that's the kind of expert-based if-else statements that we're talking about. And that also counts as AI. And really, more broadly speaking, it's any human-made system that can problem solve on its own or in conjunction with humans. So what we actually see is AI is a fairly vague concept that can mean a lot of things, but machine learning is a subset of this. It is specifically the techniques used to design and train software algorithms to learn and act on data. And you've got two different flavors here. You've got locked, and so this is where you have the data basically ahead of time, or you have adaptive, which means that the algorithm is growing and changing as more data is included. So for example, predicting weather patterns. If you've got a constant stream of new data about the weather coming in, the model can grow and adapt as the new data is incorporated. What's really interesting to know is that even the FDA has already started to take an interest in AI and machine learning. The FDA being the administration in the US that is responsible for the, I guess, the design testing of pharmaceuticals that are marketed to the public. So they're the main regulatory agency for drugs in the US. They've actually proposed this as sort of a model workflow for how in the pharmaceutical and biomedical fields we can work with machine learning. Don't worry about understanding this all today. What's really important to realize here is that the FDA has an interest in this. So people in positions of importance within the government are recognizing the need for this, but also that this is sort of a model for how AI and machine learning can be applied to biomedical sciences and to pharmaceutical research. So while we're not going to cover every single aspect of this, we are going to cover the core aspects, and these are largely things that are going to be covered in the part 2 of this workshop. All right, so with all this being said, let's actually jump now into Python. All right, so what is Python? Well, it's a programming language, comes from 1994. It's actually, believe it or not, named after Monty Python's Flying Circus, which I didn't know until I started making this PowerPoint. It's an object-oriented language. If you've never coded before, don't worry about what that means. I think you'll kind of pick up on that as we go through things. It's interpreted. This is opposed to languages like C and Java, which are compiled. Basically, this means that you can work more interactively with the coding language. You don't have to compile your whole script. If you're not familiar with the idea of an interpreted versus a compiled language, that's also okay. It's not necessary to understand that right away. It's designed for general programming, and it can be easily extended with packages. Some people call it the glue because it connects legacy programs together with modern applications. And in many ways, it's become sort of a lingua franca for the programming world. No matter what language you're most comfortable with, most people know at least a little bit of Python in many areas of computer science today. So with all that being said, let's actually jump into using Python and basically, getting started with Jupyter Notebook. So before you can do that, we need to set up Python. So hopefully most of you have gotten Anaconda at this point, but if you haven't, that's okay, because I'm actually going to go through right now how to install it. So just a really brief word about Anaconda. It's what's considered to be a package managing system for really all sorts of software. But what it's actually turned into is a really useful way to coordinate data science packages and also make it easy to get started with data science. And so that's the reason we're using it today. All right, so what you're going to do is you're going to go into your browser. You're going to search Anaconda. Don't click on any music videos. That's not, or movies. That's not why we're here. The very first link should be this. Okay, so what you're really going to want is this individual edition here. And click download. And then whatever operating system is right for you, okay, just go ahead and click the installer for that. Now I'm on a 64-bit Windows system, so this is the right one for me. Now I've already got this on my computer. Basically, you just sort of accept the default installation options unless you know that you want something different. There's really no reason to choose something different otherwise. But it'll guide you through the installation process. It's really quite straightforward. Once you click agree, it's going to install. And basically, once it's installed, And I guess I'll click this. Yeah, because I don't think it really matters a whole lot. Yeah, well, it says I've already got it on my computer. So it's not going to install for me, but it'll install for you if you don't already have it. All right, once you've got this on your computer, when you open up your start menu, you should be able to see here Anaconda 3. And you should be able to see here Anaconda Navigator, PowerShell, Jupyter Notebook, Spider. There's a few ways you can interact with Anaconda, but probably the main way that I use it is just as a way of launching Jupyter Notebook and as a package managing system. So I don't typically use the Navigator, but if you do want to use the Navigator, you can. So I'll just show you here what that looks like if you launch this. So I actually have a version of Jupyter Notebook running at the moment, so I'm going to close that. It's not very smooth, the startup process, unfortunately. They haven't quite figured out how to make this go on Windows correctly. But you'll see it in a second. There we go. So this is something of a dashboard that allows you to just really easily launch lots of data science related programs right from this nice graphical user interface, or GUI is the term we'll use. So even RStudio you can launch from here. The other thing you can do is you can have these things called environments. We'll talk about those later on. That's really not worth getting into today. But the main thing that we use Anaconda for today is going to be launching Jupyter Notebook, because it comes pre-installed with it, along with a lot of the other packages you're going to need to do data science in Python. So I think this will work. I'll try this, see if this actually works. The other day, this didn't work for me. So it might not work because I just had Jupyter Notebook open. Yeah, if this doesn't work, this is actually good. You get to see this. If this doesn't work, my tactic has just been to close this. You don't really need that anyways. And just to open it directly here, because that will typically work. All right, and when you do that, you should see something that looks like this. Okay, so let's go back to the PowerPoint, because we're basically at the end of the actual PowerPoint here. And let me go ahead and take some questions. So, and while I'm taking questions, if you don't have Anaconda and if you don't have Jupyter Notebook, make sure you are getting those, because that will be very important for what we're about to do. Okay. All right, so any questions before we jump in? Okay, so again, just to show you this, so if you've got Jupyter Notebook up and running here, you can stop it by just closing this or hitting Control C. If you're on Windows, I guess Command C if you're on Mac. Oops, there we go. Now let's try that again. So open this up, Jupyter Notebook right there. It'll launch like this. It'll look like this when it launches, and then it'll open up in your browser. Okay, is anyone not on this step? Has anyone not been able to launch this? Just want to make sure. It's okay if not. It's really important that we take the time to make sure that everyone gets on the same page, because this is really crucial to be able to participate in the workshop. Okay, Leju asks, what's the difference between PyCharm and Jupyter? Which one is better? That's a really good question. I use both actually, but let me let some other people chime in here, because like I've talked a lot already. So I don't know, Simon or Dan, do you want to chime in, or anyone else?
Well, I find Jupyter Notebook helpful because it lets you run blocks of code, but then also blocks of markdown text. So it's a little bit more visually interactive, I feel like. It gives you the same capabilities of running code as Jupyter Notebook, as PyCharm does. But PyCharm, you just only have your code, whereas in Jupyter Notebook, you can sort of annotate that code with more than just comments. And it comes in really handy when you're trying to write reports or something. But really, as far as the coding goes, they're equivalent largely. I find
Yeah.
the interface a little bit nicer to work with in Jupyter Notebook, but that's a matter of preference.
Yeah. Oh, and sorry, just really quick here. Adam asked, is it uploading your desktop file somewhere? So, okay. One thing really important to keep in mind with actually everything in most desktop applications, typically, yeah, and Serge has exactly right here. Yeah, typically, whether or not you know it, a lot of desktop applications are actually just running sort of small servers that you're connecting to. So when you see, for example, Slack as just an example of this, in many cases, Slack, Spotify, all these guys, if you look at their website version, it's very much the same. And the reason is because the website, someone else is hosting the interface. When you have it on your personal computer, your own computer is hosting that interface, but in either case, you're connecting to it in a similar way. If you look here, we're connecting to a server right now. That server is being hosted by localhost. This is as opposed to, for example, google.com, where that's a server that's being hosted by Google, right? We connect to the server, it's somewhere else. In localhost, the server is your own computer. So whether or not you're connecting to a computer that's somewhere way out on the internet, or you're connecting to your own computer, your browser can work either way. And so that's what you're basically seeing here. Hopefully that makes sense. If that doesn't make sense, really don't worry, because that's really something that is very unintuitive when you first start with computer science stuff. But yeah, just know that you can connect to stuff that's being served on your own computer from the browser, which I think is really cool. Yeah. All right. So Anna asked, do you tend to start your analysis in Jupyter Notebook when you create a pipeline, or move to PyCharm type IDE? So I'll actually take this one because I didn't answer the question earlier. So Jupyter and PyCharm, I find, are really excellent at different kinds of tasks. So for Jupyter, if I'm doing an analysis, I'll pretty much always do that in Jupyter Notebook. But if I'm doing a development project, like if I'm developing some software or a package or a website, I'll pretty much always do that in PyCharm or VS Code or something like that, because I find that those are better for like developing software, as opposed to Jupyter, which is more natural if you're like writing an analysis. That's the way I typically do it. So to your question, I typically would start an analysis in Jupyter, and if I decide to make it into a software package, I would do that part in PyCharm. Yeah. And just to show people who are watching later what PyCharm looks like, I actually don't know if this will launch right from Anaconda, so I'll launch it from my Windows subsystem. If anyone doesn't know what Windows subsystem is, I would highly recommend Googling it. It's the thing that makes Windows bearable. But basically, yeah, so this is my PyCharm. This is what it looks like. So you can see it's very complex looking when you start it, but once you understand how all of these tools work, this is a much more powerful way to write like large software applications. Yeah. Really like PyCharm. I use it a lot. All righty. Anyways, so now that we've got Jupyter up and running, let's go ahead and look at our notebook for today. So for me, when I went over here and I downloaded the code, right, that downloaded, if I look here, that downloaded to my downloads folder, okay? And so when I unzipped it, it ended up right here. So this is the IPyNB, the IPy notebook, and this is what I need to open in Jupyter. So we come over here, we find our downloads folder. We find this biomedical ML Python main. We find module 1, and we find that IPy notebook. When you click on that, it'll open it up, and it should look just like this. All right. So I'm going to give a few minutes. So everyone, please try to get to this point. If anyone is having trouble, please say something in the chat, because I promise if you're finding trouble, most people are also going to be having an issue with it as well. Or at the very least, you won't be the only one. So do please say something. And if everyone could just in the chat, if you could just type done when you've got this up and running. Okay, good. That'll just let me know that people are able to get this going. My cat is yelling at me. She doesn't like that I'm talking so loud. Okay. Yeah, I know. She should, but it's been a few weeks since we've done one of these workshops, so she's gone back to this is like her nap time. Her bed is right next to my desk. So she's gone back to the habit of of being asleep at this time and not being woken up by me yelling about Python. Okay, so it seems like most people have yeah, she prefers R. Yeah. She has good taste. So it looks like most people have gotten to this point. Yeah, so I guess you'll probably see as we go along. I'm definitely more comfortable with R than I am with Python. I use Python a lot, but I'm certainly more grounded in R. And so, you know, you may hear me accidentally say like R instead of Python a couple times, or I might say things that are disparaging about Python because I've grown to actually really like R as a language over time. I think R is a very good language for data science, but in the realm of machine learning, I really think Python is absolutely king. So I think it's necessary to know both in some respects. But just so you know what my bias is up front. But yeah, I wasn't actually trying to start a war. Please don't start debating whether R or Python is better, because that could go on forever. All right, now that we've all hopefully gotten to this point, let's go ahead and take a look at how Jupyter Notebook is working. So Jupyter Notebook is what's called an integrated development environment, or IDE. PyCharm is another kind of IDE. Basically, these are graphic user interfaces or GUIs that help you interact with Python and help you write code or scripts or what have you in Python. Now, just to show really briefly here what it looks like when you don't use an IDE, let's go ahead and open up from Anaconda the Anaconda prompt. You can either open up the PowerShell prompt or the prompt if you're on Windows. In Mac, I think you just get the terminal, but whichever one, when you open it up, you should see something that looks a bit like this. I'm going to zoom in here so you can see. Now, if I want to launch Python and interact with it, all I have to do is type Python and hit enter. And now I am in Python. I can do things in Python now. However, this is really not very user-friendly, and I can't really see what I'm doing too well here. It's a lot more efficient for me personally to do things like this, because I find this just a much easier way to keep track of the code and to keep track of what the code is actually doing. Because as you can see here, not only do you get the code, but you also get information about the code. And that is where a lot of the power of Jupyter Notebooks comes from. So without further ado, let's go ahead and print hello world. This is a very traditional way to start a programming course. And to actually do it, you can use the arrow keys or you can click. But in one way or another, what you need to do is select this block here. And it doesn't matter if it's green or blue for right now. You'll see what that means in a minute. But once you've selected this block, you're going to execute it. And the way you can do that is by hitting this run button, or you can type Control Enter or Command Enter or Shift Enter or Shift Return. It doesn't really matter which. but let's say that I type Control Enter here to run this, since that's what I'm more used to personally. You can see that what it does is it sends back this message, hello world. Okay, so let's break this down. Print is a function. The function takes an argument, and the argument in this case is the statement, hello world. Print then takes that statement and returns it to the user. So with that simple logic in mind, can anyone tell me how I would modify this block to print hello Python? And once you have the answer, feel free to put it in the chat. Okay, good. Exactly. Okay. Okay, so we got a couple of different answers, but they're all right. They're all correct. So what I could do is simply put in some double quotes here and say, hello Python. And when I execute that, it says hello Python. All right, so I'm going to stop now because this was sort of a test as well of whether or not your Python kernels are running. So just let's start there. Was everyone able to execute these two lines? Did anyone have any problems when trying to do this? No issues? Okay. If you are having an issue, please say something, because again, you know, this is something that if you're finding an issue, a lot of other people are probably going to find that issue. Okay. All right. No issue so far. Okay. In fact, one of the best parts of these workshops, I think, is when people do find issues or when I run into bugs, because that gives me a chance to show people the process of troubleshooting, which is really an important skill to learn in any language, but definitely in Python. All right, well, so let's go ahead and jump into it then, talking about Markdown. Now, Markdown is a language. It's not really a programming language, but it's a language that allows you to take plain text and convert it into formatted text. So unfortunately, when I gave you guys this Jupyter Notebook, there were some issues and I wasn't able to get this to not be formatted to begin with. But if you double click on this, it'll go back to being plain text. Okay, and that's what we really want. And also double click on this one. I did that by accident. But basically, this is what we call Markdown. This is code that turns into plain text into formatted text. So we can execute this just like we execute a code block. So you can do that with Control Enter, or you can hit the run button. I'll actually hit the run button this time so you can see what that looks like. So you can see when this executes, it prints hello world out. And this is now Markdown as opposed to Python code. To understand how this is very powerful, let's take a look at an example here. So this is all plain text, but all this plain text will be turned into formatted text when we run this Markdown block. So let's go ahead and run that now. So we can see here we've got headers. So header 1, header 2, header 3, header 4, bold, italicized, quoted, lists, tables, code. We even have pictures. Okay, so one really quick trick you can do is if you find any Markdown block, so for example, this is actually a Markdown block because all blocks are either Markdown or code typically. You can double click on it to see what the Markdown looks like. Okay. Ahmed asked, why is the text in Markdown executed without the print function? The reason is because it's not Python code. So print is a Python function, but Markdown is actually not part of the Python language. They're two different languages. Markdown blocks don't execute Python code, and Python blocks don't, code blocks don't execute any Markdown, as far as I know. So they're two different kinds of blocks. So you can either have a code block here, or you could have a Markdown block. And we'll talk in a second about how you switch between them and how you differentiate between them. Okay, so let's now talk about that exact issue. All right, so in Jupyter Notebook, you can either be in edit mode or command mode. Edit mode is what allows you to edit the contents of a block directly, whether it's a Python block or a Markdown block. You can edit the contents of that block directly. So I can enter edit mode by simply double clicking on a block if it's Markdown, or I can also enter it by hitting the enter key. So let's go ahead and execute this block. And now that we've selected it and you can see it's nicely formatted, to enter edit mode on this block, I just hit the enter key or double click. You can do it either way. Okay. Now, edit mode is designed to allow you to edit the contents of a block. Command mode allows you to modify blocks without editing their contents directly. So what does that mean? Well, let's actually show an example here. So I'm going to enter the edit mode. Okay, so now I'm in edit mode. And you can see I've got my cursor and it allows me to modify the contents of this block. So I added this text, right? So I modified the contents of the block. Now, to enter command mode, I hit the escape key. Now you can see my cursor is gone. I can no longer edit the contents of this block. That is not an option that's available to me. But what I could do is I could do other things that have to do with large-scale changes to these blocks. So for example, I could add a new block below this with the B key. So if I'm in command mode, if I hit B, I can add as many new blocks as I want. If I hit D twice, I can delete blocks. Now, let's say I want to add a new block and I want to convert it to a markdown block, because right now you can see it's a code block. The way we know that is because we see this IN and we see square brackets and colon. If we want it to be markdown instead of a code block, we can just hit the M key. Now it's markdown. If we want it to be code, we can hit the Y key. Now it's code. So I'm gonna run this so you can see that in the nice formatted view here. Add a new block is B. Convert to markdown, M. Convert to code, Y. Delete a block, D twice. So let's say that I'm in a code block here. So is there an undo button? This is a really good question. So the way I typically do any sort of undoing is by coming here. It looks like Z works for that. I typically do that by looking at the actual menu though, because I tend to be really concerned about losing all the data. So I like to be very precise just to make sure I've got the right command. But yes, you could instead, when you're in command mode, you could hit Z and it will undo your changes. And someone correct me if I'm wrong on that. Again, Python is not my native language. But yeah, Z undoes things. Okay. So again, if I'm in edit mode, hitting Z, that just puts Z's in here. I have to be in command mode to actually undo things. Okay. All right. So let's say that you start writing some markdown. So let's say I'm trying to say something like, hello, this is a markdown block. And I realized too late that actually this is a Python code block. That's really okay. Just hit escape to enter command mode and convert it with M to markdown. And now it actually is markdown. See, markdown. If I convert this back to code and try to execute it, it's going to be upset. It'll say syntax error, invalid syntax, because in Python, this is not an okay way to do things. This is not how you would write Python code. This is for markdown only. All right. So let's now do a challenge. Can you add a new block below, convert it to markdown, and use it to print Hello Jupyter in bold? And go ahead and once you have that last part, go ahead and put the markdown code in the chat. And while you're doing that, really good question here. Can you use Jupyter Notebook stand alone without Anaconda? Yes, but it's a lot easier if you use it with at least Miniconda. Miniconda is a lighter weight version of Anaconda. Anaconda is certainly the easiest way, though, to get started with it. There are also online versions of Jupyter Notebook, such as Google Colab, that you can use that are free. And so while people do this challenge, let me go ahead and show Google Colab here. If you're having trouble, especially setting up Google or setting up Jupyter Notebooks, if you search Google Colab, it says, "Welcome to the Collaboratory." And basically, you can say, make a new notebook here. So I'm going to make a new notebook. Okay, so this is close. And so it looks slightly different than the notebook that we're currently working in, but it actually works the same where you've got code and text that you can have. So let's see, I want to write some print hello world here. See that I can run that here. So, okay, not quite the same, but at least it gives you a lot of the same stuff. Okay, so Serge has it right. So this was a challenge question because I actually didn't tell you how to make bold. To find that, you would have had to have done one of a few things. You could have come back here, double-clicked on this, and then saw how we made bold text here. Or you could have looked here, double-clicked, and then saw how we made the bold text here. Now, one of the answers was to use the 3 hash symbols like this, which I want to just explain what that does because that's an important point. Now, this does make some text that appears bold, but you'll see there's this paragraph symbol right here. We call this an anchor. Right, so headings do happen to be bolded. This is what we would call a heading, or heading 3. We can also make heading 4. Which is actually almost indistinguishable from bold text, but it has this little anchor here. And basically what this is telling you is that not only is this bold text, but it is a heading, as opposed to actually bold text, which is just like this. So the distinction is subtle, but they are different. You can see when I scroll over this, it doesn't have that paragraph symbol next to it. Really good distinction to make, though. Thank you. All right, so the way I would do this is so let's say that I'm in edit mode. I would enter command mode by hitting escape. To add a new block below, I press B, convert it to markdown with M, and then to print hello Jupyter in bold, well, let's say I've got hello Jupyter here. I'll go ahead and add these next to it to make it bold. I want to just address one more thing that got said earlier. Catherine said that the only issue when installing, when opening these notebooks was that she had downloaded it to her D drive and didn't know how to navigate. So yeah, so this is why I said earlier, just make sure you're keeping track of where you're downloading stuff to, because the only real limitation to getting into the Jupyter Notebook environment is knowing how to find it. Yeah. Okay. So yeah, all right. Before we actually jump into the meat of today's lesson, let's go ahead and take a couple questions. Anybody else have any questions that they want to bring up? Any issues so far before we actually jump into how to really do stuff in Python? Okay. Well, again, if you've got any questions that come up while we're talking, feel free to put them in the chat, or feel free to wait till we get to a stopping point like this and unmute and ask out loud. All right, so let's talk about some simple objects in Python. So in Python, everything is an object. It's an object-oriented language. Everything in Python is an object. Okay, so what does that mean? Well, don't worry about entirely understanding how objects work at first. It's actually a really complicated topic that we don't typically get to until later on in more advanced Python courses. But for now, let's just recognize everything is an object, and objects have 3 things. They have a class, they have properties, and they have methods. So with those three things in mind, let's look at some simple object types in Python. The first type we're going to look at is probably the most simple type, which is Booleans, or another way to put this is logicals. Boolean or logical, it's kind of used interchangeably. Now, Booleans are a type of object in Python that are binary in the sense that they can only be true or false. Okay, so let's go ahead and execute this line here to see what happens when we print true, or when we run true. All right, it outputs true. False, false. We can also verify that these are actually Boolean objects by running the type function on one of them. So just like print is a function, type is also a function. It tells you the class of an object, any object in Python. When we run type of true, we see it says bool, and that means that true is a Boolean. Now, one really important thing to recognize is that Python is case sensitive, okay? So if I say lowercase t true instead of uppercase T true, you can see already Jupyter Notebook is trying to warn me that I've messed up here because it's not green anymore. So it's changed the color to indicate that it's not actually a Boolean anymore. But let's say I ignore Jupyter Notebook and I try to run this anyways. What happens? I get what's called a name error. Name true is not defined. Now, whenever you see an error like this in Python, double check that you haven't misspelled the name of whatever it was you were trying to type in. In this case, what Python is telling us is that the object true does not exist in Python. While true, big T, does exist, whoops, little t true does not exist. So just keep that in mind. Python is case sensitive. Okay. And same thing here. If I try to do type uppercase T, you can see, again, it changes color. Jupyter Notebook trying to warn me, but I get another name error here. Name type is not defined. Okay. So let's now talk about some of the operations that you can do on these Boolean objects. So the first one we'll talk about is AND. That's what we call a logical operator. And the AND operator is going to return true if both sides of the AND are true. Okay. Oh, sorry, there was a really, sorry, I missed some of the newer messages in the chat. So Muku asked, what about big T or true in all uppercase? So Muku is showing his R side at the moment. He asked about, what about just this? Okay, so that produces an error, and this produces an error. That's because that's an R thing. Can't do that in Python. All right, so let's go back to the AND operator. So the AND operator will produce true if both the left side and right side are true. So in this case, left and right are both true, so the whole thing is true. In this case, left is true, but right is false. Therefore, the whole thing is false. Because again, for the AND operator, both left and right have to be true for the whole thing to be true. That's the only condition in which AND produces a true. So for any of you who've taken formal logic before, this will probably feel very, very familiar. But for those of you who haven't, I just want to take this time to just really gently introduce this concept of these logical operations. All right, so let's now move on to the OR operator. The OR operator is going to produce true if at least one side is true. So you can have true and false, false and true, or true and true. All of these produce a true. Can anyone tell me what I could do to this to make it produce false? Can anyone put it in the chat what would produce a false from an OR operator? Yeah, false or false. That's right. False or false is the only way to say false. Mert is being too fancy here. We'll get to that soon, actually. How you do stuff like that. But yeah. Okay, so finally, let's look at not. Not just negates the value of a Boolean. So if I've got true, not makes it false. It's kind of like natural language, right? Not true does mean false. And if I said not false, that means true. It's just reversing the value of the Boolean. So just like in math, there is an order of operations when you do logical operations in tandem. So the order goes parentheses, not, and then or. So let's take an example here. If we combine not false and true, so we've got both the and not operators here. When we combine them like this, not goes first. So not false is what gets executed first. And then and true. So let's break this down. Whoops. So let's look at the first part, not false. Well, we know that is true. So if we wanted to figure out what this would produce, we could say, okay, well, not false is true. Therefore, this whole thing is just true and true, which is true. Right? So that's kind of like, if you think about it intellectually, that's like replacing this with true to make it easier to solve in your head. And of course, when we run this, we get true. All right, what about this one here? Not false or not true. Well, not false is true. Not true is false. But we've got an or operator, which means only one side has to be true. And because this left side evaluates to true, the whole thing is true. Not false and false. Well, so not false is true, but the and false means the whole thing is going to be false because for ands, both sides have to be true. Here's a situation where the parentheses make a difference. False and false, though, if we actually evaluate this first, this all evaluates to false, and therefore this now becomes true. So as you can see here, between these two, there's no difference except that we change the order of operations by putting parentheses between false and false. Instead of executing not false first, we have not whatever what is inside of the parentheses. And so if we look at this here, that's the equivalent of saying, you know, what's in the parentheses? Well, that's false. And that's then the equivalent of saying, if you think about it like this, not false, which is true. All right, so hopefully that's making some sense. I know these sort of examples can get really convoluted fast, which is actually why I asked this challenge question here. But before we jump into that, let me just walk you through one more time how you can think through one of these problems. So let's say I've got this example here, and I need to break it down. Okay, so let's say that I want to simplify this. Okay, so I'm going to make a new copy here. And let's say I want to first simplify this true or not true part, because that's in the parentheses, that comes first. So that's actually true. Okay, let's substitute this now. So we now know that this is actually true. And so now the problem is not false or not true. Well, not false is just true. Not true is just false. And therefore, now our problem is true or false, which is true. All right, so that's how you can think through it. And so now we know the whole thing will be true. So with that being said, what's the answer to this one without running it yourself? Can anyone tell me what the answer is? Okay, I see true. Any other ideas? Okay, we see true. I'm not going to tell you whether or not it's right until after. Okay, until after people get a chance to say. Okay, I've got a few trues here. All right, let's actually take a look at this now. Again, let's break this down. All right, open up a new code block with the B key. So let's say that we want to solve this, but we don't want to actually run it ourselves. So we might say, well, okay, the first part is not false or false. And so not false is true. So we can substitute that. True or false is true. So we can substitute this whole thing for true. False and true, because again, remember, and comes before or. So this part's going to be done first. False and true is false. True and true is true. And therefore, we're left with false or true, which is, of course, just true. And so this is how you can think through it without actually executing any code yourself. Not that you really find a lot of situations like this, but it's helpful to be able to think through it in your head. And we can see now that it does execute to true. All right. Any questions on Booleans before we move on to numerics? Okay, let's go ahead on to numerics then. Oh, really quick, you might see at some point something that looks like this, like that in Python. That is not the same thing as and. Okay, they are in some ways similar, but just bear in mind this ampersand, unlike in R, because in R you'll see ampersands like this. This ampersand does not mean the same thing as and in Python. And if you use them interchangeably, you will run into problems quickly. Same thing, this is the symbol for or in Python, but is not the same thing in, or sorry, it's the symbol for or in R. It's not the same thing in Python. And also, I think you've got like double or and double ampersands in Python as well. Again, not really what you think they are if you're coming from the R universe. So don't worry about these for now. These are actually more advanced than we're really going to get into in this workshop. If you want to look them up yourself, you're welcome to do that. I looked them up for the purposes of making this lecture and decided they really were not worth covering because there's not many situations in which you would probably find yourself using one. Okay, with all that being said, let's go on to numerics now. All right, so there are three main types of numerical objects in Python, and try not to get them confused because you can run into problems if you do. You've got ints or integers, floats or decimals, complex, or you can think of this as kind of like mixed imaginary and real numbers, okay? So ints, to make an int, you can just type one into the code block. So 1 is an example of an integer. The type of 1 we look here and we see is an int. Floats are just numerical objects that have a decimal point, okay? So 1.01 is an example of a float. And if we look at the type, we see it is a float. Complex, which you will probably not really find yourself using very often, include a real and an imaginary component. In the world, well, in certain fields, j is used to mean the square root of -1, okay? So in Python, we say j is the square root of -1. So 2 plus 2j is a complex numeric in Python. Again, you probably won't find yourself using these very often, but just in case you do, that's how you make them. All right, so let's look at some numerical methods. Oh, before we do, Search has a really good point, which is that the ampersand and the vertical line are bit operators. So yeah, he says forget about them. They're for low-level programming only. Yeah, that was kind of the impression I got too about when you would actually end up using them. Probably not really, at least not in the context of this workshop. Anmol asked, why not use the common I for imaginary? So I is actually not common to some fields. Sometimes J is the preferred nomenclature of the field. I don't know what fields that is. I think like engineering, maybe. Yeah, blame engineers. Yeah. So I think it's in engineering, I think it's a J. All right, let's go on to math operations now. So you've got sort of the run-of-the-mill stuff like addition, subtraction, multiplication, division, stuff that you're probably all familiar with. Now we've got, if you put 2 divide signs, that's actually what's called floored division. That's division, but you round it down to the next whole number. So it produces a 5. Yeah. Modulo, that's just where you find the remainder of some division. So 16 divided by 3 has a remainder of 1. And so 16 modulo 3 is 1. Exponentiation, so you just raise something to the power of something else. So 2 to the power of 5, 32. Negation, -1. It's how you just put a minus sign in front of it. Absolute value. Quick challenge question. What is the type of 22 divided by 2? And does anyone want to guess why? Okay, so you're allowed to run this one. Sorry, I'll tell you when you shouldn't be running them, when you should be trying to figure them out without running them. In this case, you're totally free to run this one. All right, so let's go ahead and run it. So if I do 22 divided by 2, you'll notice something. The output is 11.0. This is kind of a universal way of indicating in Python a float. So let's actually confirm this by looking at the type. Type of 22 divided by 2, which says float. So this is an important thing to recognize about Python. That's actually not true really in R, or at least I don't think it is. Which is that when you're dealing with numerics in Python, you actually have to be careful of float versus int, because you have operators such as the divisor that can take two ints and produce a float. And in fact, by default, the division operator produces floats, not ints. Even when the result is a whole number, it'll still make it a float. So do keep that in mind. You can't do with floats everything you can do with ints. They do different things in some cases. They've got methods associated with them that might be different in some cases. You just want to make sure you're keeping in mind when you're using one versus the other. Also, ints tend to be more efficient for really intense computations. Just keep that in mind. If you find yourself doing some really complex work, if you can work with ints, that'll probably save you a little bit of time and hassle. Okay. Anyways, so finally, just like logical operations have an order of operations okay, so one really quick point. So really good point John brings up is it just division that produces this? I honestly don't know. It's not something I really noticed much before, but let's try it with multiplication. See, multiplication is actually an int. So you can go through and try them yourself. I'm honestly not sure which ones produce ints and which ones produce floats, but it looks like definitely not all of them. Clara asks, can you make it an int or will it always be a float? So we'll get into this in a minute, but just let's start with one of the suggestions that Dan brings up, which is that if you do floor division, it will, of course, produce an int because floor division is inherently rounded. But there's other ways you can actually turn a float into an int, and we'll talk about this later. But yeah, it's a really good question. Well, we've got a whole section on type conversion in a few minutes. All right, so PEMDAS, you might have learned it in primary school if you're from the US, but it stands for parentheses, exponent, multiplication, division, addition, subtraction. This is the order in which mathematical operations are conducted. So Python does obey PEMDAS. And if you look here at this example, if we just think about this, well, if you go from left to right, this is 3 plus 5, which makes 8, times 2, which makes 16. But if Python obeys PEMDAS, it should be 5 times 2 first, because multiplication comes before addition. So 5 times 2 is 10, plus 3 is 13. So let's actually run it and see what it produces. 13. Okay, very good. Let's now try this on a more complicated example. Can anyone tell me, without running this yourself, what this produces? Okay, good, good. That's right, it produces 11. And that's because the first step is what's in the parentheses. And within the parentheses, you have mixed types. So the precedence will be for exponentiation. So this is 5 to the power of 2, 25. Then division, 25 divided by 25 is 1. Then addition, plus 2. Now the parentheses are done, and you've got a 3 sitting in here. 3 times 3, 9 plus 2, 11. However, it will be a float 11, not ints. Yeah, and that's right. It will be a float because this division produces a float. And therefore, when you do the rest of the operations, it remains a float. Okay, so this is just important to keep in mind. We can also do logical comparisons of numerics. So basically, just like you have the and symbol, true and true, you can also have assertions that are based on comparisons of numerical values. So you've got an assertion here, 9 greater than 8. This assertion can be true or it can be false. So when we run this, we see it is in fact true. And that's because 9 is greater than 8. If instead I made this 18, it now becomes false because 9 is not greater than 18. We also got less than. So 8 less than 10, that is true. Less than or equal to. 2 is equal to 2, so this does turn into true. 10 greater than or equal to 12, false. Now, here's one that people are often confused about when they're first starting. We see here equals equals. Now, equals equals is just a way of saying these two things are equivalent. Okay, so we're saying here 1 is equivalent to 2. Now, we know 1 is not equivalent to 2, so this should be false. Okay. Now we can make it true by turning this into a 1. So just so you can see how that works. Now we've also got not equal to. And the way we say that in Python is with exclamation point equals. So we're saying here 1 not equal to 2, which is true because 1 is not equal to 2. If we made them equal, it would now be false. Okay. All right, now let's go ahead and show some complex example here. So you can see you can combine logical operations and mathematical operations. What's important to keep in mind here is that when you have this combination, the mathematical operations always get executed first, okay? Unless you use parentheses, you can actually try to do that, but otherwise they'll always get executed first. So the left side of this equals equals gets executed, the right side gets equal. So if we look at this, we've got 5 squared plus 1, which is 26. And then we've got on the right side 52 divided by 2, which is 26. So the whole thing is equivalent because the left and right side are the same. They're both 26. All right, so without running this yourself, who can tell me what the result will be for this? And also tell me what the left and right sides are equal to. All right, so for anyone who actually got this right, does anyone want to unmute and explain why? Because oh, sorry, I didn't say what the right answer was. Yeah, it is true. But can anyone unmute and tell me why? You also don't have to, like, obviously no obligation to do that. It's just nice when people besides myself talk. All right, well, this time I will show you. All right, so look at the statement. The right side, there are 2 sets of parentheses. So they're nested. The innermost one gets executed first. Okay, so we first do 2 plus 3, which makes 5. And then we've got 5 divided by 5, which is 1. Now we've got -1 to the power of 1, which is -1. On the left-hand side, we've got 1j to the power of 2. If you recall, j is the square root of -1. Therefore, the square root of -1 squared is just -1. And therefore, on the left side and the right side, we have -1. And so the whole thing is equivalent, and this is true. Let's run it, confirm it is true. All right. So before we move on to strings, any questions on numerics? Okay, let's go into strings then. So strings hold text data, such as names or addresses. They're constructed when you put things in between quotes. So we see here that I've got hello world in between single quotes and hello world in between double quotes. These actually both produce a string. Hello world, hello world. If I look at the type of hello world, it says str, which is shorthand for string. There are a large variety of methods associated with strings. And there's a nice guide from W3 Schools, which you can see here. Lots of methods. But we're just going to go through a few for right now. So, for example, you can use print on strings. That'll just return whatever statement is in between the quotes. So, hello world here. You can actually concatenate strings. And so you can see here, this is hello plus world, which is the same thing as hello world, all one string. And then you've got here the dot upper method. And this converts your string to all uppercase. Now, what you'll notice, and we'll get into this a little bit later on in the workshop, but what you'll notice is that we've got this function, we've got this operator, and we've got this method, and they're all taking some argument and they're doing something to it. Essentially, these are actually all calling functions. And while we're not going to talk in detail today about how these differ from each other and why these are all valid methods for using functions in Python, just recognize that there are these different ways to use functions and operations and methods. This is probably the one that's going to be the most common when you start working with packages like pandas. But at the same time, you also do see a lot of this. This plus sign is sort of a special case that you won't see quite as often in the world of Python. Okay, for right now, though, just recognize that these are all three ways of calling methods on strings. Okay. We can also do, oh, sorry, let me pause really quick to address this. So John asks, is there no difference between the double quote and the single quote? Yeah, this is a really, really good question that I'm actually not entirely sure about. Now, if you do have quotes within quotes, you can do some really cool stuff. Like, for example, I could say, you know, my address is 123 Street Way. I don't know. That's not real. That's not a real address. But let's say I do this. Now I can have a string with a quoted string inside of it. And if I print this, it looks like this. So you can actually have quotes within quotes, which can be really useful sometimes. If you had instead done, oh, sorry. So just so you know why this is necessary, if I did it like this, and let me change this here. Let me put all this inside of single quotes. If I did it like this, you can see Jupyter Notebook's already getting upset about this. But basically, every time you do something, you have to make sure that you are not ending your quotation, because when you start with a single quote and then you put another single quote, Python thinks you're ending your quotation, which is why nesting your quotes like that can be really useful. Now, I don't know about the precedence of single over double quote. It's not really familiar to me, but hopefully, oh, okay, so it looks like Dan says that not really convention, but single quote supersedes double quote. That's cool. I had no idea, actually. So yeah, not really sure how you would use that information in practice, but I'm sure, yeah, that would come up at some point. Cool, though. Anyways, it's really not stuff that's going to come up very often in your writing of Python code, typically. So we can do logical operations with strings as well. So we say hello equal to hello, and that is true. Hello equal to world, that is false. They are not the same thing. Hello not equal to world, that is actually true. All right. So finally, let's get here into some type conversion. So now that we understand the different types of simple objects in Python, let's figure out how to convert them between each other. So let's start with an example. Let's say that I want to print the string, I am 26 years old. If I actually try to run this in Python, I get a type error. Now, this is the kind of error that you'll often get when you're first starting out because you don't exactly yet understand how types work and how you can combine them together. The type error here says can only concatenate string, not int to string. And the confusion here is that the plus operator works both on integers and on strings, but it does different things on each. There's no logical way to add an integer to a string using the same plus sign. So that's why you get this type error. Okay, so before we talk about how to solve this, let's go through how to convert between types, because that's a very important skill in Python. So let's talk about the type of integer. So you can see 1 is an integer, but you can convert it to a float using the float function. So if I say float and then I put a 1 inside of it, it makes a float of the 1. If I look at the type, we see it is, in fact, a float. You can also convert, you've got Booleans. You can also convert Booleans to integers. When you convert true to an integer, it becomes 1. Really quick question. What is the result of running this? What error results from it? And why does this operation produce that error? Okay, good, good. Division by 0. Let's try running this and see. Says division by 0, and that's because just like true can be converted to an integer and it becomes a 1, false can be converted to an integer, and when it is, it becomes a 0, and we can see that here. And you can't divide by 0. All right. You can also convert strings to ints, and so we see here we've got a string with the number 5 inside of it, and we can see that is in fact a string. And you can convert it to an int by using the int function. It becomes the integer 5 now. So we see an example of this here. 1 equals 1 in string. That's false because these are different types of objects. But if we say 1 equals int of 1, that is true. So now, can anyone tell me how I solve this? Now, I haven't told you exactly how to do it, so I want to see if you can figure it out based off of what we talked about so far. But once you have it, please put in the chat how you can fix this. I am 26 years old. Okay, very good. Yeah, very good. Okay, yeah, Lichu, that is also correct. You could also just put double quotes around it. Well, so okay, let's come up. Let's use a couple of these solutions here. So one of the solutions that I got was to use the str function. Now I didn't tell you that this function exists, but you can kind of infer it from the fact that int exists and float and bool exist. These are also functions. So str is also a type conversion function you can use. So if I do this, now it works. And that is because you've converted this 26 to a string, and now you can add it to these other strings. As Lichu points out, you can also have just put quotes around it. That's kind of the same thing. But the str function is useful because we'll see in a minute how we use variables. But if you had a variable instead of an actual number here, it would actually be really convenient to be able to use this str function. One last word about type comparisons. You can compare between types if you want to. So, one not equal to hello world is true. You can add now mathematical operations and non-equivalence. Not that you would ever really do this, but you can, just so you know. All right, so before we jump into variables, which is kind of a heavy topic, does anybody have any questions about what we talked about so far? My hope is that we'll get to the end of lists today. I don't think we're going to get to if else or functions, and that's okay. That I've allowed extra time in the next module to go over that. Can you change the operators? Like, you mean change the divide sign to do something different? Oh, I have no idea. I think you can do that in R, but I don't know. That's probably a bad idea. That would probably really mess with your code. I don't know. So Serge says that's called operator overloading. So, okay, so I guess you can do it theoretically. Interesting, though. It's a really interesting idea. See, this is what you get for asking a question. Because I think a lot of people have some experience with like looking on Stack Overflow and stuff. When people ask a question on Stack Overflow, most of the responses are going to be like, this question isn't a good question because this is not a good idea to ever do this. So do keep that in mind. This is a very normal sort of response to get for asking questions about coding stuff. But yeah, to answer your question directly, yes. But to also add like my programmer side of my brain to the mix, don't ever do that. Okay, let's talk about variables. So to understand what variables actually are in Python, it's helpful to realize that everything in Python is an object. And when you create an object in Python, it lives in your memory on your computer. Okay, so it's at a specific place in the actual RAM on your computer. And so you can actually do stuff to that object and modify it on the RAM. But the other thing you can do is you can take that object that's in your RAM and you can give it a name that's easier to keep track of. And that's essentially what a variable is. So we call these aliases, or we call these references. All these really do is point to an object that exists in memory on your computer and gives it a user-friendly name to sort of remember and to do operations with. In this case, we're going to assign the object 1 to the variable a. We do this with the equal sign. If we look now and we print a, we can see it holds this one object, or it points or references this one object. We can actually use a now as a stand-in for things such as arithmetic. Anything you can do with 1, you can now do with a, because they are the same thing. Okay. Now, one of the things that's really useful about making these sorts of references is that it allows you to take the result of some comparison and turn that into an actual variable. All right, so here's an example of this. Can anyone tell me what the result of this will be? Okay, so I see true here. All right, so let's try it. And in fact, it is true. Very good. And that is because result 1, let's take a look here. Result 1, while result 1 is false, result 2 is true because it is the result of this comparison, which returns the Boolean true. So result 2 now refers to the object true. So John asked a good question, which is, can J be an object? I actually don't know that. Oh, do you mean a variable? Like you could use J as a variable? Oh, yeah, of course. Yeah, absolutely. This is one of the things that can create confusion. Yes, R is the same way. Like, okay, so there's this whole concept that I'm really not going to get into because of the sake of time. But let's say that I assign, you really don't want to do this, but let's say that I assign print to be equal to 1. I'm technically allowed to do that. As bad of an idea as that is, print is now a variable that refers to 1. I think Python is smart enough to figure out that if you try to say print hello world, it'll actually work. Oh no, it actually doesn't work. Oh God. Oh, that's really not good. All right, so really you want to be careful here. So if you take something like print, which already refers to a built-in function within Python, and you assign this to refer to the object 1, it now no longer works as the actual print function. Because it's a reserved word, but you can see you can overwrite it, and now print no longer works. Oh man, that was probably a mistake. Whoops, I don't know how I'm gonna do the rest of this now. Well, no, it's fine. I don't think I use print anymore. Diabolical. Okay, I got you. Sorry. I was having a hard time there for a second. All right, so yeah, so really anything where you see Jupyter Notebook change the color, try not to use that as a variable. That's a good just sort of rule of thumb. Try not to use that as a name for a variable. This is up there with making infinite loops. Don't really want to do those things. Oh, here's a fun problem. What's the difference between is and equals equals? Well, often people will use these interchangeably in Python, but they really should never be used interchangeably because they actually do different things. Equals equals refers to a test of whether two values are equivalent. So the object on the left side and the object on the right side, are they equivalent values? Is actually asks the question, are they equivalent objects? And so while the distinction may seem subtle, here's an instance where it comes into play. let's say that I assign, or let's say that I have 257, and then I refer to 257 by assigning it to the variable A. So now A refers to 257. And then I say B refers to A, okay? Now, if I say A equals B, it's true because B and A both hold the value 257. And I can confirm that here. So if I look at A, 257, if I look at B, 257, okay? And A is B. That's also true because B is literally just a reference to A, and A is just a reference to 257. So they're both referring to the exact same thing. So they are literally the same thing, literally the same object. Conversely, if we assign them separately like this, and we say equals equals, they are true, but if we say is, they are not. And the reason is because while they both refer to an object holding the value 257, they don't refer to the same object holding the value 257. They're actually referring to different instances of 257. So here's a fun challenge. What happens if I repeat this example with 256 instead of 257? Why do the results change? So I'll just show this to you here because the hard part of this question is not what happens. That's pretty easy. So I changed this to 256. This is true, but now this is true. Does anyone actually know why? Just out of curiosity, there's a really cool explanation that teaches you a lot about how Python actually works, but it's a little heavy. If you're not familiar with Python yet, okay, so caching, yeah. I don't know if it's technically considered caching, but so there's a little article here that talks about it, but yeah. Well, I'm going to leave this as kind of an interesting, okay, yeah, allocation in memory. Yeah, that's right. Yeah, because all the integers between 1 and 256 in Python are already objects in memory. Exactly, pre-allocated in memory. That might be called caching search. I'm really just not sure what the terminology here is, but when you make the object, when you say 256, this is actually something that already exists in your RAM on your computer. It doesn't have to get created by Python because Python, to make things sort of easy and fast, creates a certain number of integers already in RAM. And there's a specific reason why it's the number 256 that has to do with how bytes and bits work, but don't worry about that. Dan says, if 5 is an object, can you change its value? Oh, that is a dangerous game you're playing there, Dan. I have no idea. I have never thought to try. This is the extent of how my experimentation has gone so far. And actually, all the negative numbers from -5 to -1 are also already loaded into memory, if I recall correctly. And 0 as well, obviously. Same thing with true and false. They're already loaded into memory. And same thing with all, I think all the letters in the alphabet are already loaded into memory. So, for example, if I change this to true and this to true, still works. Okay? And that's because true is already loaded into memory. If I change this to, whoa, whoops. If I change this to A and I change this to B, oh, right. Well, they should be different. Yeah. Still true. But if I say A with some weird stuff after it, oh, did that actually work still? Okay, well, I don't know why that worked. That's confusing. I don't know how I guess I don't know how the character part works. Oh, wait, no, I know. It's like, if you do it like this, though, I got it the other day to actually work. Plus str true. Well, anyways, okay, now I got it to be false. Okay, it's because a certain amount of strings are preloaded into memory as objects, and I guess for some reason I happen to call all of them just now. Anyways, this is now going to be false. Anyways, just cool stuff. Very arcade. As Serge mentions, it's just cool to see kind of how Python's working behind the scenes, I think. Anyways, with all that being said, best not to do this stuff in real life. let's talk about some complex objects now. So we're going to just get to lists today. We're going to get to the other ones in the next session. But for right now, we'll talk about lists. Actually, before I jump into that, really quick, does anybody have any questions about what we've talked about so far? I think, unfortunately, we're going to go a little bit over time. That's pretty typical with these first sessions where we also have to do the orientation. But hopefully, we won't go past 7 p.m. CST here. So, but just really quick, any questions about variables or what we've done so far? Okay, well, this gives us plenty of time to talk about lists, which is our last topic for today. So a list is simply a collection of objects that get grouped together, okay? And they have an order to them. So in this case, I make a list by creating these square brackets and putting inside of it, hello, comma, world. This is now a list containing the strings hello and world in that order. So do keep in mind, lists have an order to them. I can make a list of numbers. I can make a list of Booleans, and I can make a list of mixed types. I can even make a list that contains lists. Okay, so let's get into the methods associated with lists now. Why are these so powerful? Why are they kind of the fundamental building blocks of most Python programming for sort of most applications? Well, it's because they can be easily constructed and they can hold a pretty endless amount of information and keep it together in a particular order. So just like any object in Python, you can construct this list object by using the relevant function. So we call this a constructor function. And basically, this just creates an empty list. The more common way to do this is just by using the square brackets and putting the values inside of it. And again, lists can even create lists. Oh, God, this is what I get for like trying to show fun examples. Does anybody know any? You know, I know how to do this. From God, okay, I don't want to confuse you, but I need to fix this really quick here. So just forget what I'm about to do. Print. Just forget what I just did. Pretend like I didn't do that. Just ignore this right now. Anyways, at some point, we'll talk about what built-ins are, but we'll also talk about how packages and modules work at some point. That's not going to be today, though. Anyways, let's talk about how to, you know what, I'll just show just to see what that example is. Just in case you accidentally followed my example and did the same thing, you can now fix it yourself as well. All right. But don't worry about what this is doing. Okay, so how do I retrieve data from a list? Okay, so to retrieve data from a list, you can use indices. All right. Now, indices refer to a specific object in that list at a specific location. Remember, lists have an order to them, and the order can be used to extract a particular object from the list based off of what position in the list that object occupies. We call that the indice or index. Okay, so unlike R and some other languages, indices in Python start at 0. So the first element is element 0. Okay, so just try to wrap your head around that idea. It can be really confusing when you're first starting, but just make sure you're remembering that the first element is always 0 in Python. So to get the first element from my list here, I'm going to say my list square brackets 0. This is just the notation you use to get a particular element from a list. So the first element was 1, and we retrieved it by doing this. We can get the fourth element by doing square brackets 3. And so the fourth element, 1, 2, 3, 4 is A. So this returns A. We can also retrieve the last element from a list using -1. So last element, B, we get it by doing -1. Okay, so we're going to start with slices now, which is a slightly more complicated topic related to how you can extract values from a list. But before I do, Serge has put in the chat, I can explain zero indexing based on history of older languages related to access memory locations on the computer. That honestly sounds super interesting. I would actually love it if you could put in the chat how that is, or maybe we can talk about it next time. But I'd love to talk about that at the end for people who've got to like go do other obligations and stuff. Just for the sake of time, I'm going to try to get through the rest of the core content though. So you can also access indices using what's called a slice. And the slice follows this format: start, stop, step. Start and stop indicate where you start the slice and where you end it. And step indicates the intervals between values in the slice. You don't actually have to specify the step. If you don't specify it, it will just be 1 by default. So when I slice like this, this basically says I want all the values from the second element through the fifth element, but not including the fifth element. So I get 2, 3, and A. That is the second, third, and fourth element. So again, we sliced up to the fifth element, but not including it. So just so you know how slices are working, they're not inclusive. Now, I can also leave out the stop, and what it will do is it will take all the values from my start to the end of the list. So now I can get, instead of like this, I can actually get all the values to the end of the list like this. All right. Same thing here. If you leave the start blank, you can get all the values from the beginning up until a certain point. So I'm going to get all the values until the fourth element. 1, 2, and 3. So this is in my list 1, 2, and 3. Now with steps, you can specify the intervals that you want to get in your slice. So I'm now saying I want the values from 2 until, the values from the third element to the 10th element, not including the 10th element, and I want to go by intervals of 2. So we see here I've got the third element, 3, and then I've got the 10th element is 10, but it's not included, so the last one is 9, and I've done this in intervals of 2. So I did 3, 5, 7, 9. What we typically do is we don't talk about the step. It's not as common to use the step unless you've got some reason to. And so that will return everything. It's the same thing as just doing a step of 1, but we're here specifying a step of 2. So you can see how this is skipping every other one. You can also use steps to help reverse the order of a list. So let's say that we go from 9 to 1 backwards with intervals or steps of -1. So going back 1 each time. So now we're going backwards. This is kind of an interesting way to reverse the order of a list. 10, 9, 8, 7, 6. If we did by 2, we can see it's now 10, 8, 6, 4. If we did it by 3, 10, 7, 4. So just so you can see how this is working. All right, you can also get elements from within nested lists. That's what we would call this. We would call it a list within a list or a nested list. The nested list is the fourth element. So we get it with a 3. And you can see when we do this, it returns the list. So to get the first element in the nested list, we would do 3, 0. And that gets us A. All right. So I've now got a challenge problem here that I'm now looking at. It looks really hard, but see if you can figure it out. What does this return and why? You're allowed to run this yourself. The hard part is why. So try to explain what this is doing. Okay, so that's really close. That's really close. John, your answer is very close. Still very close. Not quite. So I think you're missing this part here. This part at the end. So, okay, let's break this down because this is a really tough challenge here. But lists are something that's so important to understand in Python. It's worthwhile for us to go through it here just a little bit at a time. So let's make this list. Okay, only H. All right, let's go ahead and try this now. So list, let's do this first part. Now, this is just a way of reversing the order of a list. So when we do this, we see it's the same thing, but it's backwards now. So let's now add, so now if we look at this, the fifth element, right? 1, 2, 3, 4, 5 is this list in here. So that's a fifth element there. Now, again, this is now going to take this list and reverse the order. So we reverse that order again on this new list that we've made. And so now we take the 0th element, or we would call this the first element, and we see it as hello world. And the reason is because we reversed the list, took the 5th element, reversed it again. Sorry, am I saying this backwards? 0th and 4th, took the 4th element, reversed it again, took the 0th element, and that was hello world. And if this is confusing, I would say play around with it, see if you can break it down, see if you can figure out how it's working, because mastering lists and what we'll talk about later, which is list comprehension, is a really, really crucial skill in a lot of just sort of quick Pythonic sort of data science, which is really nice because there are so many things that work really well if you've got a good mastery over lists that you can do in Python. All right, let's now move on to appending, just because we're sort of running out of time here. So appending is going to take a list and it's going to add something to the end. So we've got my list here and we add something to the end. We add a 1 to the end. All right, and so you can see here that it directly modifies the object in memory. Okay, so this is really, really important to recognize because unlike R, we don't do stuff like this typically in R. In R, you would like reassign it to a new variable, but in Python, you don't have to do that. You can directly modify that object in memory. Be careful of that too, because you see, we can keep doing that. We can keep running this. We can run this as long as we want. We can hold down the enter key and really make something really disgusting. That is now hard to deal with. But no worries, if you want to recreate the list as it was originally, you can just go back up here and run this block that recreates that list and references it appropriately. And so you can see we get to start over. Note something really important here. If you reference a list, if you make a variable for a list, and then you reference that variable with another variable, if you modify my list, what happens to my list too, right? So let's try this here. We take my list, append this phrase to it. What's happened to my list too? It's also been modified. Even though we ran the dot append on my list too also got changed. And that is because my list too references the same object my list references. So keep that in mind when you do this equivalence here, when you make a variable here, that variable is referencing an object. If you modify that object, the variable is also going to be modified because it's referencing the thing that got modified. All right. So this is the last two parts. You can also get the length of a list, and you can also sort a list by using the dot sort. But again, keep in mind, this is going to modify the underlying objects. So a lot of these methods modify the underlying objects. All right. So now we're out of time. Let's go ahead and take some last questions here. Anybody have questions about what we talked about so far? When should you use dot function? That is a great question. There is often the opportunity to not use it or to use it. We'll talk next time when we talk about modules, when you're probably going to want to use it and when you're probably not going to want to. Yeah, it's a really interesting topic. Why not use list plus X? Why use append? Okay, this is a really good point. So you can actually use concatenation on lists. So let's say I've got list 1, 1, 2, 3, and I've got list 2 equals 4, 5, 6. And then we say list 1 plus list 2, and we were able to do that. Now, what happens if instead I did list 1 dot append list 2? Does anyone know what this will do? All right. Now, if we look at list 1, we see, right, it's actually added it as the last element. The whole list is now the last element of list 1. So it's done two things we didn't necessarily want, which is it modified list 1. So in memory, list 1 has now been modified by the append, and it hasn't actually concatenated them the way we wanted. Now, what you're probably thinking of is what we call extend. So list 1 dot extend list 2. So now if we look at list 1, we can see it is extended. But again, this is modified list 1 in memory. So if we didn't want to do that, this might have been preferable. So like, for example, if we wanted to do what's more like a natural coding pattern for people who are more happy in R, is to do something like this, which gives you list 3. Oh, whoops, my bad. Which gives you list 3, but list 1 and list 2 have not been modified in any way. All right. Serge says list 1 plus list 2 is an example of operator overloading. I'm actually not sure what that means, actually. What does that mean in this context?
Oh, just we discussed before how you could overload operators like plus, minus, divides to do other things, and we said that was a bad idea.
Okay.
It's good. What is good for in the case of objects, which we haven't covered yet, or classes, you can provide operator overloading to make things more natural. So list 1 plus list 2 does what you expect. In some languages, string 1 plus string 2 does what you expect as well. That's all.
Okay, gotcha. So good operator overloading. Okay, gotcha.
That's why it exists in the language. So you can do stuff like this. So it's working with lists is quite natural. List 1 plus list 2 gives you what you expect.
Absolutely.
And so what they've done is they've taken the plus operator and says, whenever you use it for a list, stick all the elements together. And it's just more code that they had to write in the list class, which I won't talk about.
Absolutely.
Yep.
So it's 7 o'clock now. We're officially out of time. So anyone who's got to bounce, feel free to do so. If you want to stick around, ask any more questions, you can do that as well. If you want to if you got to leave, but you want to put a question in the chat, just go ahead and ask it, and I'll make sure that we get to it, and it will be in the video later. So if you want to put a question, you can always go back, watch the video later to see us answer it. But yeah, so if you got to go, feel free to head out. Okay, so any other questions? And just by the way, for next time, there's no homework or anything. If you got stuck on any of these challenge problems, please go back through them. The main thing that I want people to do is, if you're not feeling comfortable with Jupyter yet, to make sure you're going back, getting more comfortable with it. And if you're not comfortable with Python, one of the things that you might want to do is go back, do some of the questions on data camp. So they actually have practice problems that you can do for the data camp courses that are really, really good for sort of solidifying those skills. Because what you really want is for next time when we start talking about modules, pandas, NumPy, to not feel lost on these sort of basic concepts that we're going to be building upon in that lecture. Okay. Well, I'm going to hang around for one more minute in case anybody has any last minute questions. But other than that, thank you all so much for being here. And I'm really excited for this workshop, and yeah, looking forward to seeing you all next time. All right, great. All right, like I said, I'll hang out for about 1 more minute. Thank you all. Yeah, and I'm happy to mention the differences between R and Python because they do so much similarly, but there are just some key differences that can really trip you up if you're more familiar with one than the other. I actually started in Python, and then I got swept up into R because I was doing bioinformatics, and a lot of bioinformatics is based on R packages. And so it's actually been something of like a coming home for me to get back into Python and to start using it for software development projects. But unfortunately, my coding patterns from R are so strongly ingrained at this point that, you know, it's almost like a second language today to do Python. I don't know if other people who are sort of polyglots feel similarly, but yeah, it's an interesting thing being able to do both. So the video will be on the course website. So basically, as soon as this session ends, I'm going to put it on YouTube, and then it will be on the course website. Anmal asked, can misuse of Python ever lead to system problems? Misuse of Python. Like infinite loops or something like that? Like what do you have in mind? So in theory, most coding languages, you can really just think of them as just kind of a different way to interact with your computer. So like you download malicious software from the internet, that's going to really mess up your computer. Well, you can accomplish that same task using something like Python. And in both cases, it was just a different way to download that malicious software. So that's like an example, I guess I would say, of how even when you're in Python, you're really not protected from messing things up on your computer if you're going about things in not the best way. But Dan also brings up a good point, which is you can use virtual environments, and that can be a way to also protect other things on your computer. So if you're a Mac user, I think this is more relevant though. Isn't that right? Like, isn't Mac like sort of based on Python to some extent, like a lot of it? Mac OS. Yeah. So Mac, you can actually get a conflict between the Python that you download and the Python that's natively on your computer. See, this is why you just have to be a Windows user and learn how to use PowerShell. I'm asked, am I allowed to change the system allocated memory? I don't entirely know I don't know all the implications of that question, because I want to say sure, but there might be implications to that question I'm not familiar with. Like if you were able to, for example, again, like thinking of malicious software, if you were able to write a script that was able to modify the database in memory for some malware program, like Malwarebytes, would that be like malicious software that Python could implement? You know, something like that. I don't know. Maybe this is a good question for someone who's more of a software engineer than I am.
I mean, I don't really know about Python and system memory that much. I remember when I learned C, you had to allocate and clear things manually sometimes from the memory. And so there it could really mess you up if you forget to clear stuff. Python does that for you, but I would assume that if you want it badly enough, you could probably access system memory and mess it up. But it's less easy to do by accident than in C.
Yeah. I know that there are ways, because Python is based on C, there are ways to access that. There's APIs you can use to basically do C stuff from within Python. I think it's called Cython or something like that. And so I'm sure you could do some crazy stuff with memory if you really wanted to. But yeah. Okay, well, excellent. So if there are no more questions, thank you all so much for being here. I really think it's going to be an excellent workshop. I'm honestly really excited that we have so many people who've already completed all of the course requirements on DataCamp. Yeah, if you've got any questions or run into any issues before next time, feel free to come to our office hours or reach out to us over email, and we're always happy to help. Okay, thank you all so much, everyone. And I will look forward to seeing you all next week.
Do you have a sec to hang on after?
Yeah, sure, absolutely.
Okay.
All right, thank you, everyone. I'm going to stop recording now.